So welcome to a session titled Building Location Analytics and Mapping into Your Apps. My name is Michael Timms. I'm a lead software engineer at ESRI on one of our products that consumes the Qt framework. So we're going to go through a little bit about location and go over that product. First, I want to ask a couple questions. I know we're short on time. Does anybody know what state in the U.S. that ESRI's headquarters is located in? In the back? California. That's right. So yeah, located in California, Redlands, California. Does anybody know the owner of ESRI Inc.? Probably not if no one knew the location. How about been to an ESRI conference? Has used any ESRI software? Anything like that? Okay, great. Well, we'll go ahead and get started. So looking at our agenda, we're going to go over location in your apps, why it's important, determining your app map pattern, how the map fits into your app, whether it's a new app, existing applications, location and mapping SDK for Qt developers. And we'll go through a quick demo and I'll show some code using our API. And then we'll save the questions and answers at the end. I know we're probably a little short on time, so if there's not enough time, come catch myself or Eric Bader, Elvin Slavic. We're from ESRI. We'll be at the ESRI booth that's up in the expo. So location-aware apps. Location-enabled apps really helps you to answer two basic questions. The where and the why. So those apps assist the users to understand the situation visually, that in turn helps the users in better decision making, which results in cost savings from greater efficiency. So you can think of an example. There's officers, investigators, they're working a case. They already know generally where crime is. In addition to that knowledge, mapping over a period of months can help officers and investigators precisely view and understand underlying crime movements and patterns of crime. So by knowing where those problems are, it also provides visual means for proactively combating crime and also communicating with citizens to build support for crime. So that's just one example. We have one of our products here, ArcGIS Desktop. And these are, this is a heat map displaying just densities of crime around Lincoln, Nebraska. So you can kind of get a good idea of where you'd need to patrol certain areas. And that's just one example. So we have location for data analysis. So now that you've seen why location is important, think about your current user base and their workflows. Be thinking about how you may be able to consume the data that the user requires in a location-aware app to help solve specific problems. And then you need to determine your app map pattern. It's really location-based experience patterns. The map can serve many different purposes for displaying data in your application, or perhaps you don't really need to show a map at all. You can still have a location-aware app without showing a map on it. So we'll focus on a few design patterns to think about when determining how to present and work with the data backing your location-aware application. So it's all about the map. So this is one of the patterns. So the map is the main focus and UI interaction tool used in the application. Any data collected or analysis is performed directly through the map, and it's displayed accordingly in real time on the map. Here's an example application we have at ESRI. It's called Collector for ArcGIS. And all the data collection is done directly against the map, and you see it right away. And you can sync those edits back to a service so they're persisted. But mostly you're working with the map directly. Sort of another pattern here. The map as a navigation tool. Here you have a map to help visualize data that's already represented in some other form within the application. So it's used to help navigate through data being presented in the application. It usually uses simple cartography for the map to put more focus on other areas of the map, of the application. The map is available to provide visual support for your data. So this is a quakefeed.net screenshot, and it's earthquakes, in all different areas of the world. And the main purpose of the map is kind of making you aware of the different earthquakes that have occurred over a different period of time, but within the map it helps to navigate to these different areas. So that's one way a map can serve purpose, and location can serve purpose in your applications. The map may provide extra information in an app, so it still plays a bit of a role. However, it's not the main focus of the application. Really, you're using a map to add value to existing applications. We've got a few people this conference that they have apps, they want to go ahead and add a map to it because they know it'll be more visually appealing, or it's just going to add value and make the app a little more friendly to use. But you may already have a complete workflow without a map. So this is from NOAA. So this is weather reports here. So you get sort of a forecast, weather forecasting, and you can have the forecast really without a map, but it's nice to have a map available if you need to be able to visually see what the weather is looking like, or be able to have a good representation of the weather by looking at the map and where that weather is occurring at that moment. And then you don't need a map at all to add location info. So this is an example of a 311 citizens reporting app for the city of Redlands, California. So you take a picture. It's really volunteered geographic information. You don't need a map for reference. The app knows where you are because, like for the Qt framework, it can get access to the device's location no matter whether you have a map in it. So you can have an incident that's occurring, say for instance in this application, fill out a form and submit that information, and we know where that's occurred because we can get location. So it's still a location-aware app even though it doesn't have a map in it, and that's really, really common. So after seeing all the different design patterns of mapping applications, I'm sure you all be interested to build location-aware apps or be thinking about how you can bring location into your existing apps or new apps that you have an idea about. They allow you to do more than just adding dots on a map. It's really more to location than just kind of seeing a map and adding some points. You might be interested in building apps that would allow you to perform different analysis tasks and visualize your spatial data in maps, find addresses, get directions. We've had a few people yesterday that were asking about being able to route, and that's available with our ESRI technology in ArcGIS. Edit and manage your data in the cloud to be able to persist your data. And it would make your map more attractive and versatile if you could perform all of that above functionality locally on your machine without being connected to the internet. So we have a solution for disconnected map use and disconnected workflows. There's a number of mapping toolkits that are currently available. They may not provide all the functionality you're looking for, or they may not be fully integrated with Qt. So today we're going to use one as an example. This is the ArcGIS Runtime SDK for Qt from ESRI. And it allows you to build these great location-enabled applications using either the C++ Qt widgets API, or we actually expose our full API to a QML API as well. So I'm going to go through a little demo and some code, but I'm going to start with our website just to give you a rundown on where you can go to try our SDK. You can come here. We have downloads for Windows, Linux, and Mac. Also runs on Android and iOS, so you get libraries in these setups for those platforms. You can get information about release notes, system requirements. There's a guide section here, and this is really useful for sort of newcomers to the platform. You can get some information about the conceptual workflows of the different features that are available in the API. For instance, routing, navigating, performing analysis on your data, and so forth. QML API, C++ API reference is available. We also have a QML sample application, C++ sample application. I'll show you that in a second. But you can come here and you can actually download a standalone sample application, and we provide source code and a live sample for you to try, and then you can view the code working. And there's a forum that's available for the community, and there's a few ESRI folks on there as well that can help you with any questions that you have. So that's available. That was important. I just wanted to show you that website. Now the sample application I mentioned, you can see on the left side sort of the table of contents. We have many different API feature areas of the API, and basically what they all provide is sort of a live sample where you can come in here and you can interact with the map. This is just adding graphics on the map, but there's definitely more workflows within the sample application. And then most importantly, we have source code that's available, so you can actually view the source code that's running behind the sample. This, for instance, is using our C++ API. It's a widgets-based API. For instance, we have a graphics view for our map, and you can add these layers to the map. And this is just a good place, a good resource for maybe coming and learning a little bit more about the API. And a lot of our users will use this sample application for even kind of starting up their applications. Now another example, talked about a few of the reasons for having location and solving problems and what it can do. This is a emergency response dashboard application, and this is just an example. So we have, basically this is around the city of Berlin, and we have these different districts around that we can use as a certain layer on top of the map, and we can query information about that that layer and that information, that data that's provided. But there's an additional one that's providing this symbology where you see all these X symbols, and these are actually incidents that have occurred from emergency, so you can get attributes about the data that's being occurred, and users are reporting emergencies. But I also wanted to point out, notice when I select this district, we get these nice charts. So this is using QtCharts, and what we basically do here is we're doing analysis to query emergencies that have occurred in a certain district, and we're taking those results that are returned from the API, and I just want to show you how you can integrate that really cleanly into existing Qt UI components like QtCharts. So you can get an example, a nice bar chart of the different types of emergencies that have occurred. You can get these pie charts, and you can populate those from the data that you're receiving from the ArcGIS platform and consuming in the client API. So I'll show some code real fast because we are developers. We like to look at code here. So we have our map, and this map is a quick item. It's basically nested inside of an application window, basic QML here. So it's a quick item. You can put that up on the application window, and then you start to add what we call layers. So there's a tiled layer, and you can provide the URL to an ArcGIS backing service for that tiled layer. And really, that's all you need to really bring up that tile layer in the background. And then I mentioned some of the other types of layers that were showing features. They were showing the districts, or they were showing the incidents that are occurring. Those are displayed as feature layers. and these are bound to different feature tables. Like this one was for census, this one was for the incidents that were occurring, the incident layer, and it gets applied to the incidents feature table, which we have down here. It's coming from basically a backing table providing the data. And that gets its data also by connecting to an online service that's hosted within our ArcGIS platform. And you can provide an expression that basically filters the features that are being showed. So that's possible to do. It also kind of wanted to show above, well, we're running out of time, but essentially what the API has is it has a lot of properties, obviously, from QML. Like, for instance, this is a query feature status property, and we have notification coming off of those properties. So they all notify, for the most part, a lot of them do, whenever something has occurred. So whenever the query has finished, we receive a query feature status changed signal that emits. So we can determine whether the status is that task is in progress, that it's errored, that it's completed. And that's a common pattern that we have in our QML API that's available for the runtime SDK for Qt. And this, for instance, gets a query. You'll get back a feature result of those features that we were displaying up on the map. And from that, we have an iterator that you can get where you can iterate through. Here we have a while loop. We're iterating through these features, and we're determining whether they're a structural emergency, medical emergency, resources emergency, and basically just bumping up these counts so that we can update the charts. So I just want to kind of give you an idea. That's how most of the API looks. If I can, I'm going to come over to the iPhone. I mentioned we were a cross-platform SDK. Hopefully this works. So this is basically the companion application, and this is where the users may report the incident. So we can come in here and we can get a buffer. We have a lot of these geometry incidents that have occurred. Or a geometry API where we can buffer around certain features. We can filter the category here, say resources, and we can come in here and we can view information about a certain incident that's occurred. So we can solve that problem and then edit that data, send that back up to the service, and that'll all get persisted in the service, and that will update back in our dashboard app. Let me head back over. So that would update back in the dashboard app, and you'd see that the data was edited. So that's one kind of complete workflow that you can do. So that basically sums it up. I know we're out of time, so thank you. We have our website. I highly recommend visiting developers.arcgis.com. Come catch us at the booth. We have an ESRI booth. You can also check out ESRI, and Elvin Slavic will be presenting a demo at the Be Heard Theater at 10 o'clock. And he's going to be going through a really cool way that you can build apps really quickly. And it's all using QML. So that's a really cool thing to maybe take a look at if you guys can. So thank you. Michael Timms, here's my contact information. If you need to get a hold of me or have any questions, go ahead and email me. So do we have any questions? I know we're running short on time. Yes, in the back. So what is the pricing model? That's usually the number one question at these conferences. I don't know, Eric, if you can help me with that one. Yeah, sorry, I know we're running out of time. Yeah, basically the answer is it depends. We could probably give you a little bit more information about that at the booth if you guys have questions about licensing and that kind of stuff. No, thank you, Eric. Any other questions? We have about a minute. Well, a lot of our customers will use it on embedded devices, but they're still running Red Hat Linux within those embedded systems. As far as some of the different embedded operating systems, it's mainly the actual desktop Linux platforms, LTS, that we support right now. Yeah, Red Hat, Ubuntu, yeah. Any other questions? I think that's about all the time we have. Well, thank you guys for joining me.